Hello, everyone. Welcome. My name is Jennifer Nyman. I am a principal at Geosyntec Consultants and the coordinator of the webinar series on behalf of SERDP and ESTCP. Today's webinar will consist of a brief overview of SERDP and ESTCP, followed by two technical presentations. They will feature DoD-funded research efforts to optimize building operations through improved energy data management and analysis. First, William Livingood of NREL will discuss open source tools that help installation energy managers analyze smart meter data to make informed decisions, reduce energy waste, and meet DoD mandates. His presentation will be followed by a question and answer session. Then Chris Battisti of the U.S. Army Corps of Engineers Research and Development Center will present work to improve communication and interpretation of energy data across different organizations using standardized semantic metadata for DoD buildings. Chris's presentation will also be followed by a question and answer session. And then today we'll conclude our webinar with a Q&A session at the end that features both of our speakers. The next few slides provide some instructions for the webinar platform. You can download Zoom at the link shown here. And if you can't download Zoom, you can always view the slides using a compatible internet browser and by creating a free Zoom account. If at any point the screen freezes, you can always try pressing Control with F5, and that will perform a hard refresh of your browser. If you have any audio issues and you're accessing the audio through your computer, you can click on the arrow next to the Join Audio button and select Test Speaker and Microphone, and then follow the prompts. If you continue to have any difficulties, please call into the conference line shown here. For technical difficulties, you can also submit a comment through the chat box, but please use the chat box only for comments related to technical difficulties. The Q&A option should be reserved for questions for the speakers. And if you continue to have technical difficulties, you can always download a PDF of the slides at the link here, and you can call into the conference line. Finally, we will be live streaming this webinar on the SERDP and ESTCP YouTube channel at the link shown here. Today's broadcast is listen only. You may submit questions using the Q&A box that is on your screen. You don't have to wait until that Q&A period to submit your questions. And in fact, we encourage you to please submit questions in advance of that session. And when you type in a question, please add your organizational name at the end of your question. With that, I would like to introduce Mr. Timothy Tétrault, who is the ESTCP Program Manager for Installation Energy and Water. Before joining SERDP and ESTCP, Tim worked at NREL, where he focused on energy efficiency and renewable energy project development for the federal sector. Tim.
Thank you, Jennifer, and welcome everybody to today's SERDP ESTCP webinar. Like Jennifer said, I'm going to give you a quick overview of the programs and then hand it back to Jennifer to introduce our first speaker. The SERDP is the Strategic Environmental Research and Development Program. It was established in '91 by Congress as a partnership between Department of Defense, Department of Energy, and EPA. And the program's mission is to identify and address high-priority environmental science and technology opportunities that focus on DoD requirements. SERDP funds both fundamental research as well as advanced technology development that ultimately impact real-world environmental management. And then ESTCP is the Environmental Security Technology Certification Program, in which we demonstrate innovative environmental and energy technologies. And these investments capitalize on past investments under SERDP or other research programs and are designed to transition technologies out of the lab and into the field. And especially important in all of these projects and demonstrations is the ultimate transition to implementation and regulatory acceptance. SERDP and ESTCP are complementary programs with much of SERDP research occurring in the lab and at pilot scale with an occasional field effort, while ESTCP demonstrations are primarily at the pilot and field scale, although occasional supporting lab efforts are conducted. There are several environmental drivers for the type of work funded by SERDP and ESTCP with the underlying objective of sustaining DoD ranges, facilities, and operations. And this, as you can imagine, is a broad undertaking and can take the shape or take the form of looking at maritime sustainability, threatened endangered species, climate impacts, unexploded ordnance and munitions constituents, as well as other environmental drivers. And one of the key environmental driver is the reduction of current and future environmental liabilities. This involves addressing contamination from past practices, including impacts to groundwater, soils, and sediments, UXO contamination, and developing management approaches for contaminants of emerging concern. The second part of this is pollution prevention with the focus on eliminating likely environmental pollutants or hazardous materials in manufacturing, maintenance, and operations on our installations. We have several main focus areas for research and demonstration in SERDP and ESTCP as shown here. And as mentioned earlier, technology transfer is very important within SERDP and ESTCP programs. Technology transfer efforts include the development of videos, training workshops, and guidance documents. And the webinar series is a substantial component of our technology transfer efforts. Our webinar series highlights research and demonstration efforts from all of our program areas. And the last webinar in 21 will focus on forensic techniques for differentiating PFAS sources. And registration for the 2022 webinars will be available soon. And you can find additional information about upcoming webinars at this link here. And as well, all of our past webinars are archived and can be accessed at that site. Finally, the 2021 SERDP ESTCP Symposium is coming up just the week after Thanksgiving. This virtual event, again, this year virtual, and we were next year hopefully to be in person again, will be between November 30 and December 3rd, and will showcase the latest technologies that enhance DoD's mission through improved environmental and energy performance. And I encourage you all to register for the symposium, and you'll be able to see more in-depth presentations on a range of research areas that are currently funded in the programs. And finally, I'd like to remind you that a copy of the presentation of today's session can be downloaded from the webinar page. And at the conclusion of the presentation, we'd appreciate if you could please take a moment and complete the survey that will pop up on your screen. And with that, I will hand it back to Jennifer, and I hope you enjoy the webinar today.
Great, thank you, Tim. It's now my pleasure to introduce our first speaker. Bill Livingood is an expert in building energy analysis, computational thermal analysis, and data acquisition. As manager of the Commercial Buildings Research Team at NREL, Bill oversees the development of next-generation simulation capabilities and guidance documents, such as the Advanced Energy Design Guides that provide building and U.S. climate zone-specific design recommendations. Bill is also an inventor on 3 patents for power generation technologies. He earned a master's degree in chemistry from the University of Nevada, Reno, and a master's degree in engineering from the University of California, Irvine. Bill, please proceed.
Hey, thanks, Jennifer. Hello, everyone. Thanks for taking the time to join today's session. Before jumping in, I just wanted to make note, this is a larger effort. There's so many terrific contributions from so many. It's a larger NREL team. I want to communicate appreciation towards. Also, the Navy Smart Grid team. We could not have accomplished this without them. They're so integral to the accomplishments, and of course the ESTCP program. Many thanks to all those. Today, I'm going to be focused on processes and open source tools for transforming raw utility meter data into actionable insights. The presentation will follow this outline displayed on this slide. Okay, before jumping into the problem statement, I did want to give a little bit of background. The ESTCP program followed a very meticulous, systematic discipline process to arrive at this problem statement. This is not the NREL team's problem statement. And through this process, the ESTCP program relied a lot on interviewing energy managers across the DoD services. And through that, they arrived at these key elements provided in this problem statement slide, if you will. So installation energy managers communicated across DoD that they need better tools in order to track trends, identify anomalies. But most of all, I'm just kind of hitting some of the highlights here, they really need more user-friendly systems to take a tremendous amount of raw data from utility meters, building automation systems, a number of other sensors, if you will, data sources, and transform that into action. So there's a big gap there, and that's what we aim to accomplish through this effort. A key element here is the Open Actionable Insights platform, which is merely a collection of Department of Energy funded open source software tools. And so a lot of this is about bridging Department of Defense investments in utilizing utility meter data and combining that with some very powerful resources that the Department of Energy has been investing in over the years. And by making this bridge, we're hoping longer term that it facilitates a strong collaboration between the Department of Defense and Department of Energy. The key objective here, again, is to integrate DOE and NREL's OAIP, or this collection of open source resources, with the Navy Smart Grid program. Okay, just digging down a little bit deeper, what are the specific features or functionalities that we're working towards? Well, one, there is just a tremendous amount of information that's contained in asset management platforms. But rarely is that asset management information being combined with measured meter data or measured data from building automation systems. And so we're really missing out on some additional context. And so we want to be able to scrape the various asset management databases that are out there across the Department of Defense and combine that with measured data to now provide some unique insights that haven't been available before. The next piece is the Department of Energy has invested a lot of money in developing automated fault detection and diagnostics algorithms and resources. There are also a number of algorithms that are available through universities and the private sector. And so we want to make sure that those are more readily available and accessible to the Department of Defense services. Next, there's a lot of talk about digital twins and all the functionality and features that they can provide. So we want to, through a pilot, prove out how information from asset management sources, as well as a number of other data sources, can be used to auto-generate digital twins. It's clear that digital twins provide value. The question is the expense at which developing them, does it really provide a sufficient return on investment? And so we wanted to pilot automated processes for developing these digital twins so that we improve the economics around them. And then finally, in order for us to really take advantage of all the powerful features of controls and meter data, we really need to improve interoperability. And so we're, through this project, taking some baby steps, doing some proof of concepts of showing certain types of interoperability improvements can really make a difference in reducing soft costs. Okay, just maybe going up to a 30,000-foot view. I want to just kind of discuss how this is a broader impact across all the federal agencies and Department of Defense services. So for the purpose of this specific ESTCP project, we're very focused on the Navy's needs and working very closely with the Navy Smart Grid team. With that said, we're trying to do this development and this interconnection of the software tools across DoD and DOE such that it has broader impacts and it could benefit the Air Force, Army, and GSA. And so the key premise here that we're trying to follow is that there's a lot of terrific databases that already exist within the federal agencies. And what we want to do is we want to be able to take some of which is the unstructured data or uncoordinated data across the databases and use some of these DOE investments to provide a greater structure, a greater context to that data so that we can quickly get to more actionable insights, but more impactful outcomes, if you will. So what you see here in terms of the outcomes are our key goals, and that is for ESA compliance tracking. Again, the main title of this project, transforming raw data into actionable insights. But we also want to provide a means for greater accountability across the Department of Defense and ensuring that we're all working towards greater energy efficiency. With the Biden administration, there's a lot of strong interest in a new development called building performance standards, particularly applied to federal buildings. So that's coming, and we think through these investments we can more quickly get to that point. And then finally, we really want to inspire scaled interventions and achieve greater performance. Okay, one quick point here is that in the previous slide and in this slide, I included the word roadmap, and I really want to stress the word roadmap here. In many ways, just trying to keep these schematics or diagrams simpler and easier to digest. I'm leaving out a lot of details. I'm also speaking a lot to what are our longer term goals as opposed to exactly where we are today. So it has definitely a vision element. Not all of these aspects are available today. So please keep that in mind as I'm walking through this workflow. And during the Q&A session, glad to dive into that element to greater depths if you have interest. So key piece here is we want to take asset management information from INVADS and Maximo and utilize some data taxonomies that the Department of Defense have helped fund and co-developed with industry, and insert that into an open source database that's specifically designed to handle various forms of building data and building characteristics and be a repository, reliable repository for building characteristics, if you will. Through the course of this project, we are trying to tightly couple these databases with existing Navy databases. So one of which is the Navy Smart Grid database of choice. OSI Soft Pi is the private sector tool, as well as the circuits database that's been around for some time that stores a lot of meter data that's very valuable. And then ultimately, we want to be able to create some algorithms to allow for CTS type compliance tracking. That one is more of an eventuality, not in existence today, but more in existence today with the Navy Smart Grid project is dashboards, automated fault detection diagnostics, and now with this partnership, the producing the asset-driven KPI and visualizations that go along with it. I'm going to just touch upon this real quickly. Again, we're hoping that the benefits of this effort span much beyond the original target of Navy, and that others can observe, what we have accomplished, take a look of what we produced in these open source resources and utilize them in their own efforts. So the Army Corps of Engineers, and one of my co-presenters, of course, is from the Army Corps, is doing some fantastic work with some platforms developed for better management of building energy data, facility energy data. And this speaks to some of which the DOE resources that they're utilizing. Maybe one quick note again, I stressed the word roadmap. This is more of a vision. Not all of these elements are in place. And Army Corps could choose, different endpoints and not exactly follow this, of course. But, just wanted to get this out here. Maybe one other quick note, Energy Star Portfolio Manager could benefit this process, but there's also some challenges from a cybersecurity standpoint, and that might not be, likely is not feasible, but many of these other resources and integration are definitely of benefit. Okay, I think it would be worthwhile to maybe take a step back and just talk about the Navy Smart Grid program, and particularly its existing software architecture. So this is what is in place today, and this is evolving and will continue to evolve with time. But what you see here is a number of different platforms and even information technology network segmentations or enclaves that have different security levels, if you will. And through this, you see where the OSI Soft Pi system is used to collect electric meter data, sub-meter data, as well as building automation system data, many different acronyms for building automation systems. BCS is included in this diagram, but also SCADA systems, PLCs, and distributed control systems. Pi is very good at gathering up data. Many drivers are available to gather up that data. That then gets rolled up to an enterprise level instance of the Pi database, and then is utilized with other analytics engines, if you will, to provide more actionable insights. And so this is a terrific resource that provides a lot of outstanding capabilities. And what we really aim to do then is to build upon this, provide open source solutions that would dovetail and strengthen the capabilities of this platform. Now, from a conceptual perspective of how the Department of Energy's open source tools are fitting in with that Navy Smart Grid system that I just displayed there. So one is DOE's SEED platform, and then the data taxonomy building sync used for transforming energy audit data in a convenient electronic format so that it enables more electronic workflows, if you will, to really extend the number of uses for energy audit information. And how can we take all those energy audits that are being performed and then have those benefit some of the asset management practices that are taking place? And so that's one area where open source software is used to facilitate and add capability, if you will. In addition, in order to really make use of this information, you're going to hear a lot more about this with the next speaker's session, is how can we improve interoperability so that automated faulty detection and diagnostics and other features can be provided with lower soft costs, with less site-by-site configuration, if you will, with with automated fault detection and diagnostics. There's platforms to implement that, but in terms of extensive libraries, that's an area where Navy definitely sought for additional resources, and that's where we contributed in a big way. And then finally, to provide greater insights, digital twins running in real time with physical twin measurements oftentimes gives insights to anomalies that allows people to take actions. And so that's where the fourth element fits in. Okay, I'm going to skim over this real fast because my colleague's going to dive into this, but all of these features are possible, but the question is can we make it economically feasible? And semantic interoperability, making greater improvements in semantic interoperability will allow us to take advantage of all these advanced features. It allows us to take advantage of that by improving the economics, by reducing the installation time and extensive site-by-site customization. So that's a big element, and you're going to hear a lot about that in the coming session. Okay, for project status, we're not exactly, our period of performance is not exactly lined up with the federal fiscal year, nor even the calendar year. So, but regardless, this is a good indication of our progress so far. We're getting to a point where we're starting to close out a number of items. And of course, we want all these resources to be utilized. They're open source resources, and we really want many more to benefit across the Department of Defense complex, as well as private sector entities that find them valuable. Just going through a quick pass here. First, we started with a data inventory, make sure that we understood all the different data sets that were available across the Navy. We then, armed with that information, worked with the Navy Smart Grid team and looked for the key areas where we wanted to integrate this Department of Energy open source software. Then we created a mock-up of the Navy Smart Grid system so that we could make those connections in an expedited fashion without risking Navy installation operation. Then we progressed with those key elements that I described earlier, with asset-driven KPIs, AFDD, algorithm library, producing automated digital twins, improving interoperability, and then ultimately we'll get into a deployment stage. And again, I think that's what's so great about this webinar is this can really help initiate that deployment follow-on phases, if you will, where we can pass on these resources to other entities, and we're hoping that those entities take these resources and really run with them and benefit from them. Okay, now digging in to each one of those elements on that Gantt chart, simplified Gantt chart, if you will. The accomplishments to date, did a thorough review of the many different data sets that are available in order to make sure that we thought about the right applications and algorithms to process those raw data sets. In this case, AMI, of course, means smart higher time resolution meters that have been deployed widely across Department of Defense. Okay, for this integration, we wanted it zeroed in and with a heavy focus of more immediate relevancy to the Navy. And so we really wanted to focus in on use cases that were of most value to the Navy. So we developed a number of different use cases and iterated with the Navy, making sure that we had their priority influence the selection, really direct the selection of the use cases that we would then do the following subsequent steps of integrating these different software packages, if you will. Let's see here. In addition, to help enable some of these workflows, sometimes we did more than just software development and interconnection of software packages. In some cases, for example, we created an RFP template, if you will, that the Navy could run with when they're procuring future energy audits, such that the outputs would follow consistent data taxonomies so that those energy audit outputs could be more readily used in many more use cases than they are today. Okay, next piece is developing the Navy Smart Grid Mockup. This is really important so that we could have an accelerated development path, that it didn't get bogged down in various approvals at too early of a stage. So this really provided us a necessary mock-up or sandbox, if you will, so that we could show the various software packages interconnected. Navy could view both the value of that and the effort needed to make that happen, and then that gave them the confidence for subsequent future steps, if you will. It also provided a de-risking pathway, risk mitigation pathway for their eventual adoption and incorporation of these algorithms and analytics and software integration for their future efforts. Okay, key element here again is there's so much effort that is put into asset management because it's a necessary effort for large institutions. They're just handling so many different pumps, fans, motors. The only way to keep track of that and ensure that they're running smoothly and doing the appropriate maintenance on them is to use those asset management systems that are offered by a number of private sector entities. And so that effort, though, could benefit so much more than it is today. And so we want to be able to extract data from those asset management systems and use that as further input to, let's say, just multivariate regression analysis, as well as other forms of more advanced machine learning type regression analysis that then will just provide much greater insights into energy consumption. If you are just using energy and normalized with weather and square footage alone, it just doesn't provide a strong enough correlation coefficient within those regressions, oftentimes to really identify the priority buildings, facilities that need interventions, if you will, just because there's so many other confounding factors. But bringing in the asset management data to that mix then does allow you to provide greater differentiation to increase your correlation coefficients, if you will, so that you have greater confidence in taking action forward. Okay, automated fault detection diagnostics is not a new concept. It's been in research for decades, but putting it into practice has proven to be challenging from an economic standpoint, but its adoption is growing year over year, and we envision that growth will continue because it's just really helpful for facility managers, building managers. There's a number of different categories of AFDD, and so we're trying to provide resources in a number of those different categories so that Navy can experience the different forms of AFDD and benefit from a broader approach to AFDD, but also make note of which categories they feel are most relevant to their needs, and perhaps they could, probably they would want to keep a broader perspective and use all these various categories, but in some cases, for certain circumstances, they may want to prioritize certain categories of AFDD over others at times. So this experience will really be very helpful for them as they go through that. Digital twins, this is where maybe just kind of going back to maybe somewhat of a more elementary definition of it is we're simply creating a virtual representation of a building or a facility, and that virtual representation or model would be run in real time and compared with measurements from sensors with the physical twin, if you will. And when those don't match up, that often means there's some sort of anomaly happening, and signals to facility managers that they ought to investigate further and take action. And so digital twins in certain sectors across our economy are getting a lot of uptake and have proven to be very valuable in terms of predictive maintenance and whatnot. The problem is for buildings is that they can be costly to develop. And so we're trying to create more automated means to do that. Just looking at the time, I'm going to zoom ahead here a little bit. Again, for interoperability, you're going to hear a lot about that with the next speaker, so I'm going to glance over that. So benefits to DoD, there's just a lot of investment by the Department of Energy that's benefiting so many private sector entities. We want to make sure that there's a bridge that exists with these really impactful efforts by NAVFAC, by Army Corps, many other Navy DoD organizations. And so if we feel if we create this bridge, provide a pathway for DoD to more readily adopt these open source resources, it will create a longer term benefit, collaboration, if you will, that will significantly reduce the carbon footprint of Department of Defense. As a recap, we're starting with the Navy, but we're really hoping that these resources are utilized across a broader group of stakeholders across the federal agencies. With that, I'll close and happy to take any questions. I think Jennifer may moderate that portion.
Yes, thank you so much, Bill. Thanks for the presentation. I'll remind our audience at this time that you can submit questions by typing them into the Q&A option that is on the Zoom screen. And we have received a number of questions. So Bill, the first is about databases. What kind of databases are being used to store the data? Are they SQL servers or databases?
Yeah, so there's a mix of database technologies that are being utilized, but SQL databases are certainly in that mix of the resources that are used.
Okay, and then we have received a number of questions about cybersecurity. Well, the first two are related, and they're about first, that facility systems are often isolated from the enterprise network and public internet, which has been a hurdle to implementing solutions across DoD. So how can you address those cyber concerns? And then I think similarly, what about crossing between security enclaves and extracting KPIs?
Yeah, so we have not dove in very deeply on many of the cybersecurity aspects at this phase of the project. That is in our upcoming steps. But I want to make couple quick notes that many of these resources, just to be clear, are open source packages that are made available, where Department of Defense could have their own instance of it, like for example, the seed database behind their own firewalls and their own practices, if you will. It leverages many more readily utilized open source solutions as an underpinning. So we're hoping that those two elements make it easier to achieve the cybersecurity approvals. But certainly those are very real challenges that do need to be addressed. We're not fully there in addressing all of those and achieving ATOs, for example, for all elements that you saw today. We're hoping to work with the Navy Smart Grid team to work through that in the latter phases of this project. At first, we wanted to prove out some of the functionalities and the values with the mockup. Now we can use the mockup for some early evaluation of cybersecurity elements, but ultimately more of that's going to be needed to be done by the Navy Smart Grid team itself.
Okay, understood. Thank you. Next, under task 4, you indicated that 3 to 5 KPIs have been scoped out. Can you elaborate or provide me more information on those KPIs, what they are?
Yeah, so many of these are going to be very familiar to you today. For those that are involved in evaluating building performance. So even, for example, EUI or energy on a per square foot basis, including weather normalization elements, that would be one of those KPIs, but it would be paired with, okay, what assets exist within that building, and then have a normalization, if kind of a separate normalization or another input variable to the multivariate regression analysis, so that projected EUI is more indicative of actual performance, as opposed to externalities that you can't control from a facility manager perspective. So in other words, let's say that a facility has a kitchen with a lot of fryers and other refrigeration equipment. Just having note of that, then we can take perspective of what a higher EUI would mean. It could be that higher EUI for that facility makes sense because of that cooking facility within that building. So that would be one. Other KPIs, again, that would be very familiar, are just sensitivity analysis associated with energy consumption and cooling degree days or heating degree days. But again, with the overlay of having more insights about the equipment within that building.
Great, thank you, Bill. When is the audit template with standardized format going to be available? So
in the road, maybe one quick note. The audit template tool is available today. On the workflow that I showed in terms of the roadmap, I did indicate it being able to provide insights into, like, for example, INFADS and Maximo. That part is more of a vision or a goal aspect. There is not a direct link today. We're hoping to get to the point, and I think there's that's in part because of cybersecurity type concerns, but we're hoping that we can get to a point where audit template tool output, which comes in the form of this data taxonomy standard that's now being guided by ASHRAE, Building Sync, and funded by Department of Energy, that there could be a human in the loop, easy, convenient upload to a tool like InFADS and Maximo. So just wanted to make note of that line connection, both in the Army workflow diagram as well as the Navy's, a little bit visionary. Now, it's my understanding that our Army Corps is already utilizing the audit template tool, maybe not exactly how that workflow roadmap indicated, but they are leveraging it today. Maybe I'm not sure the next speaker has much awareness of that, but Army Corps can speak to that use today.
And Bill, we have one more question for you. Can you describe how these newly developed analytics are relevant to the recent emphasis on accelerating decarbonization?
Yeah, absolutely. So there's with this greater emphasis on decarbonization, I can tell you now that the Department of Energy is already gearing up to make more significant investments in carbon tracking, as well as making note of which energy conservation measures have bigger impacts on decarbonization even from a cost effectiveness standpoint, right? So Department of Energy is going to make a lot of investments on algorithms and analytics to provide that. And so now by creating this bridge between the Department of Energy and Department of Defense can more readily adopt those algorithms within their platforms and benefit from those platforms because we're establishing this bridge.
Wonderful. That was an excellent wrap up. Thank you so much, Bill. And we'll have Bill back on the line later in the webinar to answer some more questions.
Great, thanks.
Thank you. Our next speaker is Chris Battisti. He's a research mechanical engineer working in the Building Energy Systems team for the U.S. Army Corps of Engineers Engineer Research and Development Center's Construction Engineering Research Laboratory. Mr. Battisti's primary research focus is on HVAC controls, facility-related control system integration, and recommissioning. He received a bachelor's degree in mechanical engineering from the University of Wyoming and a master's degree in project management from Colorado State Global Campus. Chris, please proceed.
Great, thank you. Oh, apologies for jumping ahead. Okay, yeah, thanks for the introduction. I'd like to second Bill's thanks for ESTCP for funding this demonstration. I think it's really important, and thank you to Bill for having a really good lead into this discussion based on interoperability. So today I want to talk about our demonstration that we're going to try to standardize semantic metadata on HVAC control systems. And so I'd like to also point out that we're teaming up. So I work for the Construction Engineering Research Lab. We're teaming up with NREL, and I think a lot of the people who work on Bill's project are also working on this project. So I think there's a lot of good synergy between these two projects, and it's pretty exciting to work on. All right, so this is my project outline. So first I'm going to kind of go through what a typical system architecture looks like in a building control system in the DoD and in industry in general. And I think this is an important start, kind of get some background on how many of our systems are actually set up, because for us to be able to have data flow upwards from the systems itself to a higher level data analytic platform, you need to understand how everything is connected. Then I'm going to go through what semantic metadata is exactly, and also what data schema is already out there. I think that will also highlight why a demonstration like this is needed for the DoD. And then I'm going to go through how this can be applied to building control systems based on what I talked about earlier with system architectures, and then why this will help in installations and what would get installation staff, what installation staff would get out of metadata in their systems. All right, so this might be obvious to everybody on the call, but the DoD has a lot of buildings. There's over 275,000 buildings around the world. And now, not all of them will have like a modern building control system. We do have a lot of buildings out there that actually still have pneumatics. There's buildings out there that might only need a space heater. because it's a garage. There's also other systems that I think someone asked in the question earlier about being isolated. But in general, there's still a lot of building control systems. Now, because of government contracting, we need to install control systems that I like to call as open as possible, which I'm sure I stole that term from somebody, but basically we can't install true open systems because those aren't really available for open bid purposes. So to help with that, we, over the last 15 to 20 years, there has been several Unified Facilities Guide specifications that have specified communication protocols to be as open as possible. And that goes through BACnet, LawnWorks, and Niagara Systems. And even though, like, for example, BACnet is held up as a fairly standard communication protocol, that standard is, I don't know if anybody's ever opened it, but it's like 1,200 pages, and there's a lot of different options to meet the BACnet standard that can still be proprietary. So we have a pretty in-depth spec to help with that. And it also allows for multiple vendors to win projects because we need to have an open bid system unless you want to go through the sole source justification process. So we also have some stuff on the utility monitoring control system, which is where you would interact with your control system at installation level. And if you have any questions on those, just as a side note, all those specs are available on the Whole Building Design Guide website, and you can shoot me an email if you're curious about them. Anyway, so there's been a lot of good work put in the effort of interoperability already and integration, but there are still a lot of problems with interoperability that when the installations actually receive their control systems. Because of the need for an open bid, unless you go through that sole source justification, which is a lot of work, and I'm sure some people would know that on this call, but the installation probably has multiple controls vendors they inherit from construction projects. And I know there's installations out there that have put a lot of effort and money into getting to as few vendors as possible, but that still is a huge undertaking and a lot of work for installation staff. So let's say you're an installation with multiple control system vendors. They also have multiple controls front ends to monitor with their operators. And so every one of those has a different way to navigate graphics or look at alarms, download trend data, override points, anything to control that system from somewhere. It's more complicated because there's different types of systems. And so operators have to learn multiple interfaces. And you might be thinking to yourself, well, that's what they need to do, right? But that can be really difficult with how different they can be. So this is where interoperability comes into play. And if we can get those systems to interoperate, it makes it a lot easier for operators. So now we're going to look at kind of what the DoD control systems look like now if you go to the field. All right, so this is what our current control systems kind of look like. So just to keep in mind, if all potential data is actually available to the installation. So a lot of you out there might be thinking to yourself, I don't have a lighting control system connected to this, or I don't have a supervisory controller or my meter standalone. But this is in general, if I could send my data all the way up to data analytic platforms, this is in general what it would look like. Also take note in the top right, the EMIS and FDD, so Energy Management Information Systems, EMIS, and Fault Detection Diagnostics. There's a cloud around that, and I think someone brought that up earlier about cloud servers. That's just a general showing of this can be connected to these platforms for data analytics. So there are people out there who provide those at the installation, but most of the industry does have a cloud solution. So I just wanted to represent that here. All right, so how would I know how my building control system is actually operating well? The only way to do that is through data analysis. So this could be as simple as just looking at graphic user interfaces. This could be graphing trend data in Excel to something more advanced like fault detection and diagnostic algorithms and digital twins and everything Bill was talking about earlier. But those analysis are based on what the data is representing. So you can't, if you don't know what the data is actually telling you, it's hard to do analysis on it if it's just a point. If you pull a data trend, and if you've ever done this, usually it'll provide the point name, what the data point is, and a timestamp. And it could be fairly simple, like air handling unit 1 supplier temperature. And if you pull that, you might know what that is because you pulled the data and you're looking, you know what it's doing. But if you then send it to me and say, hey, Chris, can you take a look at this data point for me? I want to know if my air handling system is working well. I would send you back a bunch of questions like, Where's the ARHU located? Where's the building located? Is the building actually occupied? I would want a lot more context around that point to tell you if it's actually working well or not. So think about that when it comes to a data analysis platform. It's not me as a person, but it needs to know that context as well to provide good analysis. So historically, to take care of that, there's been standard naming conventions. The Unified Facilities Criteria has standard naming conventions, but frankly, a lot of times they're just not followed. Control system vendors have their standards that they put in, and it saves them a lot of time if they just use their standards. And it's hard to QC those from a new construction standpoint. And even then, standards can change by location. So an installation, an Army installation might have a different standard than a Navy installation from an Air Force installation. And that lack of standard and accessibility really limits the benefits of the DoD could be obtaining from all this data. And so that's where we're going to get into this demonstration a bit. And we're going to have another example of this, of why the context is important. Without that context for the data, installations become less resilient because it's much more reliant on individual knowledge of the installation. If you have a controls tech or an HVAC tech who's been there for 25 years and retires, they will take all that information and context with them. And it's hard to transfer that from one person to another. If you've ever taken over a job from someone else, you'll understand what I'm saying. So the below graphic electric data trend graph is pretty informative with the labels. We put labels on there to say, hey, there's a training holiday, there's a federal holiday, which might suggest why the energy usage is lower those days. But I still don't know what building this is. I don't know what the schedule is on that data graph. There's still a lot that I can learn from it. And maybe that actually is that operating properly or is it not operating properly? There's still a lot more context that can be provided to me just looking at that graph to tell me if it is or not. All right, so now we know context is important. I've talked about that a bunch, but what does metadata have to do with it? So metadata provides that context. It helps analysis through that context. And a good analogy is finding a book in the library. So if you don't know what you're looking for, a library is just frankly a confusing building full of books. So, and even if you do know what you're looking for, if you don't have the layout of the library and you don't know where anything's located at, it's gonna be pretty difficult for you to find that mystery novel you're trying to check out. The same can be said for building data. When your data has that metadata, it allows for people who don't know the system to navigate it a lot easier. And when I say other people, I can also mean an EMIS platform or FDD. Something that accepts that data and automatically does something with it that is useful. Without metadata, setting up that automatic nature of these platforms becomes a lot more cumbersome and a lot more costly. And that's what Bill was touching on in the last presentation is it becomes a lot harder to do a lot of these advanced use cases for our control system data when we don't have that kind of context. And we have to go through each one of those 200,000+ buildings. All right, I've sold you on metadata now, right? So we're good. Demonstration, we can call it good. But you know, the great part is that to implement it as well, your data points probably already include a lot of that metadata inherently, and we just need to extract it and attach it. So ideally, this is done from the beginning of a new project. During design and construction, you can define what these are and attach them to the data as part of construction and during the programming phase. And this would also be done retroactively for an existing building, but obviously that's a lot harder if you don't need to gather all that context and provide that. But again, this can be extracted. This isn't something where we're stuck, you know, oh, my building's already built, I can't do this now. If this is something that you can go back and still do and provide a meaning to that data. So what's this demonstration about? Like, why are we looking to standardize? Well, if we standardize the approach, the format, and the conventions of attaching the metadata to their points, and we apply that same standard across the DoD or even within a service of the DoD, or even an installation, all of a sudden we have a lot of data points for those 275,000 buildings that are a lot easier to access and do something with. The processes for viewing, analyzing, auditing, and much more can be done similarly from installation to installation. So if you have a roving energy audit team that goes from installation to installation, they're not having to figure out the new system when they go to a new installation. It should be the same throughout the entire service or the DoD. And figuring out different control system front ends suddenly becomes a lot easier from a manual standpoint and an automation standpoint. And this is what hammers home the interoperability point that Bill was talking about earlier as well, of where if we can interoperate between different control systems, just operating our buildings from a macro level becomes a lot easier. All right, so I'll be the first to say, we're not breaking new ground here. So we're not demonstrating something that hasn't been thought about before. Standardizing metadata schemas has been going on for getting close to a decade now. And the two most well-known are Brick and Project Haystack. So I'll start with Haystack because I believe it started first. Haystack is built around a dictionary tags, and they provide different information about the system to the points. And that was started by controls and data analytic companies. And then Brick has a structure built around relationships for the different points to describe the assets the points are showing. And that has been worked on by academia and controls companies. And we'll say, what's nice about this demonstration, we have several people from NREL who is working on this demonstration, partnering with us, who work on both of these. So we have a lot of good expertise in this demonstration to help implement that properly. But there's two of these, right? So even in the standardization realm, there's more than one standard. So we can't lean on the fact that industry is standardized something right now and we're ready to go, let's just run with it. And so metadata can be pretty hard to think about. It's a pretty abstract thing to picture in your head. I know when I first started learning about it, I had to rethink about what it actually meant a lot. So this slide is just showing what they can look like visually. So as you can see, Brick on the left shows that relationship between the points. And it might be hard to see on your screen, but you get the gist. It's basically providing those different relationships by point, and it can get much more complicated than this. And then Haystack's on the right, where it shows the different metadata links associated with this example of variable error volume box. If you're curious more about these, both of these provide pretty good examples on their website, and the link is to those websites are at the end of this presentation. So again, this isn't a competition. So something to keep in mind is it's not like Project Haystack and Brick are fighting each other for dominance over the schema or the metadata schema realm, right? The goal is to enable interoperability between the systems. So ASHRAE has started to work on standard 223P to help coordinate those two standards for standardization. And this demonstration is working to show the benefits of that standardization in the DoD. And while also providing the DoD where we are trying to go from there. And I want to really stress, we want interoperability. We want to have our control system be interoperable, and that's what this research is focusing on. All right, so we're going to go back to our original little system architecture that I showed earlier. Where exactly do we attach the metadata? Where is it applied at? And there's a few options. So luckily there's a few options because, like I talked about earlier, every building is different. So lots of buildings in the DoD do not have a supervisory controller in their building. So while that is an option for certain controllers out there, that if you don't have it, that's fine. If you have a UMCS operator workstation, which if you have a UMCS, you should have an operator workstation, it can be applied there. It can also be applied at an EMIS platform. And part of this demonstration is to explore those different options and see which is best for the DoD and give that. Because again, if you don't have an EMIS platform, that's not an option for your installation. And this slide is just showing this isn't about a single building. If we had one single building, metadata would not be as a concern to me because it's one building, even if it's a really large building. This is about an installation that potentially has hundreds or thousands of buildings on their UMCS. And at a service level, we're talking tens to hundreds of thousands of buildings that's going to apply to it. All of a sudden, that contextualization becomes significantly more important and becomes very appealing, but also is a huge undertaking that we need to start working towards. So great, what are the benefits? What are we going to do with this metadata? And Bill went through a lot of it. There's some other stuff too. So we went through the benefits of EMIS and FDD platforms, but can also help standardize things that operators and technicians are affected by every day, such as graphical user interfaces and sequence of operations. So If a GUI can look the same throughout the installation building graphics, it can make it much easier to troubleshoot potential problems. And something as simple as where a supply air temperature data point is located on a graphic can help make this a little bit easier for them to troubleshoot problems. And you can also bring operators from different installations potentially, and they can see something similar that they've seen at their installation. Another thing is the sequence of operation standards. Those are changed and updated pretty regularly industry-wide, and a pretty well-known one right now is Guideline 36, which is high efficiency sequences. If you want to implement that at your building in your installation, that could take a while because you have to go system by system, and metadata can do this in a much more streamlined and higher level way. It can also help with traditional data analysis and trending. For example, if it's a hot day outside and you want to see if your air handlers are providing the temperatures are needed to cool the administration buildings, you can use metadata to search for supplier temperature, AHUs, and administration buildings and pull up just that specific data rather than going to specific buildings and looking at them individually. All right. So what are the benefits to the DoD specifically? So when we standardize across the DoD, again, easier implementation for EMIS and FDD, which we don't really have right now that I know of. I know some installations I think are using something like this, but it becomes a lot easier to implement FDD and EMIS. It allows for interoperability between vendors. So if you have several different control vendors on one installation, if you can have them go to all to an EMIS platform and provide one graphical user interface, that becomes a lot easier for you to monitor your systems. And this also provides potential data analysis on a service level. It's just a lot easier to connect those points to installate if you have that metadata on it. And standardization reduces labor and cost. If you apply it during installation of the control systems in the beginning, it makes it just a lot easier, so you're not coming up with something new every project. When you have metadata, everything, basically operation of the building improves from a soft standpoint. So metadata by itself isn't going to do much for you because it'll just sit there, but it enables FDD, EMIS, everything we've talked about earlier, and allows for better monitoring of the system. So your commissioning, your recommissioning, any ongoing commissioning becomes a lot easier. If you want to start building custom dashboards for your installation, you can do that significantly easier and on a global scale rather than building to building, bringing in points individually with metadata. Allows for better measurement and verification. And getting back to asset management, it allows to connect to asset management platforms and provide that data and give you more information. But again, this is all dependent on how it's utilized. Metadata by itself isn't going to do anything for you. So the big thing that I always harp on in general is training for installation staff on how to use it. So if we start putting it in, we have to make sure we have the training available to installation staff. Getting close to my time, so I'm going to rush through real quick. So there's been a big push for smart buildings to provide more data to users. And to kind of look forward a little bit here, standardizations allow for the future addition of schema for non-traditional control system use cases. There's been a big push for more occupancy analysis. Gunshot detection is another thing that's becoming more popular. And then obviously with the COVID pandemic, indoor air quality, and in general with mold's a big issue in the DoD. This allows for standardizing of those kind of systems as well. So with this product, we're determining a path forward on standardizing what that metadata schema looks like. It also looks like we expect to show that it can be implemented easily on new projects, but also what it would look like on DDC renovations, and then potentially implement on high energy use or critical buildings. So for our demonstration, we're looking at a building on 2 different demonstration sites. We're also doing an observation site that actually has a similar project going on right now through an ESPC. So we're going to implement the metadata to those system types, and then we're going to identify high use cases that highlight how metadata would help the installation. And there's the additional resources I brought up earlier. Go to those sites. I think they'll send out a link, a copy of the presentation to everybody who registered. So go there. Great information about these sites. They're open source. They have a really good, everything's really there. It's pretty great. Thank you.
Great. Thank you, Chris. To our audience, you can submit questions to Chris using the Q&A box on your screen. So please do that now. Chris, can you tell us what some use cases you will be investigating in the demonstration are?
All right, so we talked about FTD and EMIS. I'm not necessarily looking to reevaluate how good both of those things are. There's been a lot of research on that. There's other demonstrations doing that. I'd like to look more, especially at the asset management, measurement, verification, and graphical and dashboard, as I was talking about earlier. That's more of an installation might be able to do that themselves. And then also, I think someone earlier brought up a bunch of questions earlier about cybersecurity. So can we help pull reports using metadata on inventories for cybersecurity inventory to help an installation get their authority to operate? So we're going to look at what can we use metadata for to help everyday issues in the installation beyond just FTD and EMIS.
Great, thank you. And can you talk about the applicability of SERL TR-14-15, if you're familiar with that and if it does apply here?
I'm not, and I might be familiar with it, but I don't think I can associate the number with it. Someone could write what that report was, that might be helpful.
Okay, so if the audience member who asked that question could provide a little more information on that, please. Chris, the next question is, what kind of systems are you targeting for the demonstration?
It really depends on the demonstration site. So I think that what typically people would want is like a VAV system, but it just depends on what we can find. So one of the sites we were looking at has a heat pump system, which I think talking about decarbonization would be great to look at doing it for heat pumps. So that's really what's dependent, but we're focusing on HVAC systems. And then like the hydronic system should be pretty consistent. So we've talked about doing central plants, but first priority would probably be VAV system, but I will take a heat pump system as well.
Okay, as a follow-up, besides the HVAC points, is metadata also applicable to utility meters and sub-meters?
Oh yeah.
Okay.
Yeah, we're definitely doing meter stuff. So part of it too, it's a good point, I didn't bring that up with the use cases. We want to look at how, when we attach metadata to meter data, how it looks like when it gets sent up to MDMS, to like through eaters to all that stuff, kind of like what Bill went through earlier. So we'll definitely be applying it to meters. That's really important.
Great. And how are you going to investigate economic payback for the metadata?
Yeah, that's a tough one because it's really a soft savings, right? Again, metadata doesn't do anything by itself. So we want to look at some of those use cases and see, will it help if I want to implement a sequence across a building? Does that make my life a lot easier? We're going to talk to FTD and EMIS vendors and see what some cost savings would be if you have metadata versus not, because going into and retroactively putting metadata by itself and seeing if that would be cheaper to do metadata first and then the FTD platform. So we're going to be doing a lot of economic analysis based on those soft savings.
Great. Thanks, Chris. And at this time, we would like to bring Bill back to answer some questions. The first question, Bill, we'll start with you. What are your recommendations for lowering the cost of installing advanced building controls in analytics?
Yeah, so I think real quick, the private sector offers some really powerful solutions, and so I think it's just crucial to bring those private sector offerings to the fold and enable Department of Defense to benefit from them. The trouble right now is the economics in some circumstances can be challenging because of the site-by-site configuration that has to happen to make those a reality. And so through interoperability efforts that Chris dug into, I think by making advancements on those fronts where the metadata is more plentiful, but it's also structured and has a consistency across projects across the Department of Defense, would just make it a heck of a lot easier for these private sector entities to roll out their products. And so I'm really excited to be helping to advance, through the Navy Smart Grid program, greater interoperability. But I'm also really excited about Chris's projects. I just think it's so important to push ahead with that. And we have seen some federal agencies like GSA start to also make headway on this front. So I think continued focus on minimizing that site-by-site customization by having a greater consistency with metadata is going to be a crucial element. There's other elements if we have time, but I think I'll pause there to allow for some other questions, but happy to dive in further if there's interest.
And Chris, is there anything you would like to add to what Bill said to that one?
No, I think he hit the nail on the head there. It's, if you go from installation to installation, it's really difficult to get this stuff figured out. And I don't think we should have any interest in developing everything new just for the DoD. And the private sector is doing really, really good things. I think the GSA effort Bill brought up is a really good sign of that. And the thing is, the GSA can do that as a whole. That's their job, versus the DoD has a different missions than the GSA. And so if we can negotiate rather than installation to installation, or even building by building, rather than go even region by region in installation, just makes life a lot easier for these installations. And they have a hard enough job as is. Let's try to make it easier for them.
Great. Along those lines, Chris, can you describe what DoD installation personnel can do to prepare their systems to assist in interoperability?
Yeah, I think kind of going back to that system architecture I brought up earlier, making sure data in your facilities actually get to your UMCS and because that's a problem, is when you have a big cyber network, it can cause issues if you have a lot of data flowing back and forth. I think of one installation in particular, but it can cause a lot of challenge. And if you can't get data to that central UMCS, you're not going to be able to get data up to what Bill's talking about. There's also the cybersecurity aspect, which people talked about earlier, is the risk, going through the risk management framework and getting your authority to operate is really, really, really important for this. The private industry is doing a lot of stuff, again, on the cloud network, and people have differing opinions on the cloud, sending something to the cloud, but no matter what, if you're gonna want to be able to do that in the future, you need your ATIA to be able to do that. So I know a lot of people are working really hard on getting their ATO, and that's a cumbersome process, but it will be worth it, not just for national security, but also to help you operate your buildings better.
Okay. Thank you, Chris. We have two more questions that are specific to your presentation, Chris. First, will you consider energy and demand flexibility in building controls? And do you see standardized quantifications of energy flexibility a gap?
Yes to both. It's kind of beyond this, but yes, I think that's the point, and that's the point of this project, is like to make stuff like that easier, right? Because energy flexibility, or doing stuff based on demand costs, or it's all just so much easier if you have metadata. You can do it individual building by building, but it's just a lot more complicated. My goal isn't necessarily to strive and say these are the things you'd absolutely need to use metadata for. It's, here's the metadata. We've come up with this standard, and now you start doing the buildings. Now go forth and do good things with it. And energy flexibility is certainly one of them.
Thank you. Bill, a question for you. Can you describe some barriers to the mass adoption of advanced building controls now?
Yeah, so I think we hit upon this semantic interoperability aspect. That's again, I'm going to, sorry for being broken record, but that's a really crucial one. But in addition to that, I think there are techniques for more automated configuration, if you will. So we are seeing technologies, and this is not a replacement for the semantic interoperability efforts. It would be a complement to it, where there's more automated point mapping algorithms and processes that the private sector, as well as the research community, are bringing to the fold. So that's a key element. Obviously, there's a number of tough questions about cybersecurity. That's a big deal that's really slowing things down. So we need to continue to make investments to streamline the approval process, but yet at the same time provide very robust solutions. So, for example, BACnet, the BACnet community, which is a derivative, if you will, of ASHRAE SSPC 135, have released early provisions on BACnet Secure Connect. That is not, to my knowledge, been fully deployed by private sector entities quite yet. I think probably there's a number of private sector entities considering it. So something like that, or alternatives, I think would also streamline the installation process to achieve a greater mass adoption. And I think continue to just making these data streams, if you will, from asset management systems and many other data sources combine. Some people refer to that as almost like a data fusion process. Department of Defense uses data fusion technologies for kind of the battle theater. It's also important in facilities operation where we're doing data fusion processes. And so I think Department of Defense has a lot of key insights on that domain where we can pull in lots of different data sets for more robust insights. I think that would provide more immediately actionable insights that, again, could lead to a greater adoption.
Okay, great. Thank you so much. Chris, is there anything you would like to add to that about barriers to kind of mass adoption?
Getting, I think, senior leaders interested in interoperability, I think, is a big thing too. I think some are interested in it, but I do think when it comes to especially the decarbonization side of, there's a lot of focus on, microgrids or solar, or EV, and all important, very important stuff. Not to say those aren't important, but this is a really important part of that process. And I think making sure senior leaders understand that and getting their support is going to be key to moving this forward.
Okay, understood. And at this time, I'd like to thank both Chris and Bill for the wonderful presentations and for answering questions so thoroughly. Thank you both. And our next webinar in this series, as we wrap up, is on Thursday, December 9th in the Environmental Restoration Program area. And this webinar will focus on research on forensic techniques for differentiating PFAS sources. Registration is open, so please visit the webinar webpage to register for future webinars. Before we conclude, I'd like to remind you both the audio and a copy of the presentation from today's session will be archived on our webinar webpage in case you want to refer to them in the future. And we would appreciate it if you could please take a moment to complete the survey that will pop up on your screen at this time. This concludes today's webcast. Thank you.